Hello, everyone. I am Cody, and my other teammates are Ricardo and Brenda. We designed a hand crank rotating plate for our term project for Engineering Design 1. Our goals for this project are to design and develop an innovative rotating plate that enhances convenience, efficiency, and functionality while also finding ways to incorporate a smooth rotation and sturdy base. Another goal this semester was to learn how to effectively use SolidWorks to complete our project. On the next slide, you will see an animation for our full assembly. Our design started as a four-sided base, but after research and feedback, we decided to use one that is three-sided. This should enhance the durability of the base. We also changed the design of the stationary part to avoid any chance that it could rotate when it shouldn't. We also modified some parts throughout the design process to fit without the use of screws.
So, a little background on our design. So, we wanted to improve a Lazy Susan. A Lazy Susan is a manual rotating plate that is a multi purpose functional plate to display items. By improving our design of a Lazy Susan, was to add a handle so we could control the speed with bearing balls for a smoother rotation. The purpose of this was to have an affordable, durable, and sustainable plate for consumers. Some highlight that we came up while researching was coming up with the bearing balls design for a smoother rotation. Also, the material for our design so it could have strength and wear resistance with the friction and load on it, the plate as well. Here is a animation of the base that we created. We created a three-legged base with a stationary with an extruded triangle. This is where the stationary connector is, or this animation would show where the bearing balls were held with our connector of the gear.
Hello everyone, my name is Ricardo and I'm part of the Lazy Susan project team on MN 130. In this slide, you can see the motion study for the parts I was responsible for designing in SolidWorks. A handle for control, an internal gear for smooth manual rotation, and a custom holder for stability. In the future, I plan to enhance the Lazy Susan with ball bearings for smoother rotation, non-slip pads for better grip, and modular sections for easier cleaning and customization. Some challenges I faced included simulating rotation in SolidWorks, dealing with warping on large prints, and enhancing tight tolerances for gear alignment. I tackle those by using motion studies, adjusting slicer settings, and modifying my design for better print fit. We chose the Lazy Susan project for this semester to solve a very common problem: difficulty reaching items across large tables, especially during group meals or even at work and office spaces. To solve this, we designed a manually rotating platform that makes sharing items much easier. With a smooth rotation and a built-in handle for control, the design allows users to bring items closer without reaching or standing up. The bonus is how much easier it becomes to clean up and organize the table. Items can be grouped, moved, or removed quickly. It also improves safety. This project was a valuable hands-on experience for us, helping apply core SolidWorks skills from motion studies to design iterations while solving a real world challenge.